Good morning. We're going to start chapter 27, a very long chapter with all the words. There's 43 or 44 words in this chapter. And the first assignment for this chapter is due on April 21st, the feast of St. Anselm. And we're going to do words 1 through 13. And the first word up there you can see is the solar system. From solaris, solare, pertaining to the sun, and system, Greek word to place together. So the sun and all of the planets and other bodies that travel around it. Now what are these other bodies? Of course they are the moons. And in our case we have a lot of artificial moons called satellites going around our Earth. Next word is planet, Greek plantelos, to wander, roam. Any of the primary bodies that orbit the sun, a similar body that orbits another star. So obviously when we get to the other planets, you're going to see that they have an orbit, and Kepler defined the orbits, and we'll talk about that a little later. The next word is solar nebula. That occurred on page 32, in word 32 in chapter 1, sorry. So you've had this before. There is the same root for solaris and nebula, nebulae, feminine, mist, fog, vapor. So a rotating cloud of gas and dust from which the sun and planets form. Also, any nebula from which stars and planets may form. Our sun, most important thing to remember, has 99% of all the matter in our solar system. It seems almost an impossible thing to think that our sun has 99%. So how insignificant the rest of our planets and we are compared to the amount of matter in the sun. The next word then is nebular hypothesis, and that is formulated, and you had this word before too, by Pierre-Simon the Marquis de Laplace, way back in 1776. And what did he say? A hypothesis that the sun and the planets condensed out of a spinning cloud of gas and dust. If we go up to the picture, this is one from your textbook, it's just this rotating mass. And of course, as it rotates and so forth, it begins then to gravity begins to pull it in. And if you get a solar nebula, then eventually maybe you'll get the sun. We have a whole chapter on the sun, and we'll pick that idea of the solar nebula when we get to that chapter of the sun. Next word, please. Look at planetesimal. That is the same root, of course. What is it? A small body from which a planet originated in the earlier stages of development of the solar system. Once that is, in other words, the main sun is out there, and the little particles left may form a planetesimal. And then later, when that becomes more and more by gravity pulled together, it becomes a protoplanet, a larger body of matter that formed from the coalescence of the planetesimals in the solar nebula. So that is, then you have these review questions to do, but we're going to do more words because we want to divide this chapter up into even words for each time you do it. So the next word, now this is very interesting. You have the Aristotelian model and the Ptolemaic model, and we have other models coming up. So model is a man-made representation of something that occurs in nature. Back to chapter 1 again. And here we have the Aristotelian from Aristotle, a Greek philosopher who lived way back, and then modus, modi, masculine, and standard of measurement. So a geocentric model of the solar system in which the sun, stars, and planets revolve around the Earth. Oh, that seems to be very important. We want to put the Earth in the center. Now, Aristotle wasn't dumb. What does it look like? It looks like every morning the sun comes up and goes around and settles. It looks like the sun, from simple observation, goes around. But the problem with that is you can't explain why sometimes those other wandering planets like Mars or Venus sometimes are an evening star, sometimes they're a morning star that you can see out. They didn't know when. And how do you explain that? Well, the Ptolemaic model is a geocentric model of the universe in which the planets had two motions, a revolution around the Earth and a series of small circles to explain what appears to be retrograde motion. So how does Venus and Mars retrograde and seem to go around? So they made these little tiny things called epicycles. Geocentric is another one, Earth-centered. So this really goes all the way to change these two because they don't seem to quite answer the question. So let's look at this picture though. The Copernican model is the geocentric, is a heliocentric model, please. These two are geocentric models. So the Aristotelian, Ptolemaic are geocentric. And you can see the Earth in the center of the Sun. And to get these things with retrograde motions, they made little artificial, what they called epicycles. And that explained at least what they observed. Copernicus came along and said, well, let's put the Sun in the center, then all the planets go around. The only epicycle we have is the Moon going around us, instead of all these epicycles. And we now know that Copernicus was correct, at least saying that the Sun was the center of our, he said, universe. And that was wrong now. We know the Sun is only the center of our solar system. They thought that all the fixed stars were out there. So now you have the three models. What are they? The Aristotelian model, and then you have the Ptolemaic model, a modification of Aristotle's model, and then you have Copernicus with the heliocentric model. Thank you. Can we go up to the next words then? So what is this retrograde motion? Retro in Latin is backward, and gradior, gradi, grassum, est, to step or walk. And movio, movere, movi, motum, to move, stir, set in motion. If you look at all these kind of roots, you can figure these things out if you know your Latin. The backward motion of movement east to west instead of the usual motion of west to east. So that's retrograde motion. And then what did Ptolemy say? He got this epicycle, a small circular motion of planets within their orbits, proposed as an explanation for the retrograde motion. So here is the Copernican model. Notice his dates. Okay, and he was a priest actually, and a heliocentric model of the solar system in which the Earth and the other planets revolve around the Sun. All planets move in the same direction around and at varying distances from the Sun. That's very, very important. It isn't until Kepler comes along that he uses all of this to get all the different motions of the planets, the speed of the planets, and all that. We'll talk about that a little later. Next word that you have is Galileo. Oh, I missed this. Heliocentric, sun-centered. Galileo. Galileo and Copernicus. Look at the dates. They were he follows the Copernicus. What does he say? Father of experimental science. Galileo observed the motions of the planets with the newly invented telescope, word you had last chapter, and proved that the heliocentric model of the solar system was correct. Stated that terrestrial gravity causes all objects to accelerate the same amount regardless of their mass, and the rate of that acceleration is constant. And of course, Kepler then even goes further a little later. I think as far as we're supposed to go is word 14. So do notice that the words go a little further than the reading section, but do the words in the reading section, fill them out, fill out the paper, And then the next section will go on to the next words, which is due then on the 22nd of April. So the first one, this one, remember, is due on the 21st, St. Anselm's Day, and that's where we're going to stop now today. Thank you very much. I hope you're all well, and know that I miss you all. My Earth Science Lab is so quiet, I can't figure it out. Thank you. Bye-bye.